Good morning, students. In the last class, we discussed about how to find out the empirical formula and molecular formula in some basic concepts of chemistry. Okay. So in today's class, we will discuss about stoichiometry and stoichiometric calculation. Okay. Stoichiometry and stoichiometric calculation is very important for 2 or 3 months. They may ask based on the questions they'll ask. Okay, I'll give one example for you. First, listen, students, what is stoichiometry? Okay, so listen, stoichion means it is a Greek word which means element. Okay, stoichion means a Greek word which means element. Metric means it is also a Greek word that means measure. So the measure of the elements is called as stoichiometry according to Greek word. Understood? The measure of the element is called as stoichiometry. How with example, how can I say this? And take the combustion of methane. Combustion of methane means this methane burns in presence of air. This is called combustion. Okay, gives, of course, when the hydrocarbons undergoes combustion, they always form CO2 plus H2O. Okay, so students, here 4 hydrogen atoms are there. To balance that, you write 2H2O. Here count the number of oxygen atoms here. 2 plus 2, 4 is there. Here only 2, that is 2. This is called what? Balancing the reaction. In only the balanced chemical reaction, we can easily explain the stoichiometry. Okay, in the balancing the reaction, some rules are there. Trial and error method is there. Okay, oxidation and hydrogen method is there, and also oxidation number method is there. So in the chapter reduction reaction, I'll explain how the equations will balance. But now just you understood, number of the reactant molecules and the number of the product molecules should be equal because this should satisfy law of mass action. Means the mass of the reactants must be equal to what? Mass of the products. Okay. So students, here if nothing is there means 1 is there. Here nothing is there is 1 is there. Okay. That means these 1, 2, 1, 2 are what? Stoichiometric coefficients. That means how many moles of this oxygen required to complete burn this CH4, complete combustion of this methane. This is what? The balanced chemical reaction. So how the stoichiometry applies here? Listen, if we consider this one as 1 mole, okay, here 1 mole. So here required 2 mole. So this one is 1 mole, this one is 2 moles. Understand? So students, 1 mole of methane requires 2 mole of oxygen to produce 1 mole of carbon dioxide and 2 mole of oxygen. This is 2 mole of water molecule. This is the way to read the reaction. Understand? 1 mole of methane requires 2 moles of oxygen to undergo complete combustion to produce 1 mole of carbon dioxide and 2 mole of water. Okay, so if we want to write this equation in mass form, okay, so this CH4 means 1 carbon 12 plus 4 hydrogen. The molecular mass of CH4 is 16 gram. Okay, so here oxygen molecule is there. One molecule of oxygen O2 is 32 gram. Like the two molecules are there, that is 64 gram. Here CO2 is 1 carbon plus 2 oxygen, that is 44 gram. You may calculate yourself. Okay, 1 into carbon plus 2 into oxygen. 12 plus 36 gives, sorry, 12 plus 32 gives 44. Okay. Next, H2O means 2 into H2 plus oxygen. That is, H2O means its molecular mass is 18. That is 36. So students, if you had both, you will get the same answer. 64 plus 16 means 80. 64, 70, 80. Here also, 44 plus 36 means 80. So the law of conservation of mass is satisfied. Understand? So here students, how can you read this equation in the gram value? Means 16 gram of methane requires 64 gram of oxygen to undergo combustion, complete combustion, to produce 44 gram of CO2 and 36 gram of H2O. Understand? So this is the one way, another way to read the equation. Understood? You may write this also in the words. Next, if you want to read it in, this is in mole, this is in gram. If you want this in volume, 1 mole volume means 22.4 liter. 1 mole means, in the last class in the mole concept I said 1 mole may be equal to atomic mass, 1 mole may be equal to molecular mass, 1 mole may be equal to 22.4 liter, 1 mole may be equal to 22,400 cm3. Okay, so in volume we have to say 22.4 liter, that is 1 mole, reacts with 2 moles, means requires 2 moles of oxygen, means that is 44.8 liter. What I am combining, remember, 1 mole of methane means 16 gram. 1 mole of a substance means 22.4 gram. Okay, here 2 mole of oxygen 64 gram. 2 mole means 44.8 gram. Don't confuse. How can I take this value? Okay, here we mentioned 2 mole, 1 mole, and we know what is 1 mole, 2 mole value in gram, mass, and as well as number of atoms also. Later I will say. Next, here 1 mole means 22.4 liter of CO2 and 44.8 liter of H2O. How can you say in volume? Means, so the volume of 22.4 liter volume of CH4 requires 44.8 liter volume of oxygen to undergo complete combustion to produce 22.4 liter volume of CO2 and 44.8 liter volume of H2O. Remember, here we used 1 mole. 1 mole of CH4 reacts with 2 mole to give 1 mole of CO2 and 2 mole of. Here we mentioned about only mole. Here 16 gram of methane reacts with 64 gram. Here we are explaining them in what? Grams only. Now here 22.4 liter volume of. So can you observe the difference here? So here we are mentioning mole, gram, value. Understood? So 22.4 liter volume of methane combines with undergoes combustion in presence of 44.8 liter of oxygen gives 22.4 liter of this carbon dioxide and 44.8 liter of that H2O. Okay, and last one, if we want to say in terms of atoms. So 1 mole of atoms, students, you know, that is equal to Avogadro number, that is 6.022 into 10 power 23. Here 2 moles means 2 into this value, that is 12.044 into 10 power 23. So this one 1 mole means 6.023 into 10 power 23. This one is 12.044 into 10 power 23. Okay, so that means the 6.022 into 10 power 23 atoms of CH4 requires 12.044 into 10 power 23 atoms of oxygen to form 6.023 into 10 power 23 atoms, sorry, molecules of CO2 because it is a molecule. So, and 12.044 into 10 power 23 molecules of water. Understood? So this is the way to write. This is the comparison value. So students, they may ask the question. How they will ask? Listen. If here 16 gram of that methane combines with here, like that some values they given as. If they given 2 gram of methane completely bond in presence of oxygen to give carbon dioxide and as well as water molecule, then how much oxygen is required? So this is the main reaction. This is the main reaction. By comparing with this reaction, students, if CH4, 16 gram of CH4 combines means, sorry, undergoes decomposition means it gives 44 gram of carbon dioxide. I'll write here, then you will easily understand. If 2 gram of CH4 is burns in presence of air completely, then how much CO2 is produced? This is the question. Means 2 gram of CH4 burns means how much CO2 is produced? That is the question. Remember here, they are asking for CH4 and CO2. No need to consider this, but you have to write the complete reaction. CH4 plus 2O2 gives rise to CO2 plus 2H2O. By comparing these students, consider these two values. Means 16 gram of CH4 gives, okay, how many grams? 44 gram of CO2. Okay, so in the question they given 2 gram of CH4. Then how many gram of CO2 will produce? If you just cross multiply, you take it as x. These two multiplied, these two multiplied. If you want to x means that is 44 into 2 gram divided by 16. Then you get the value. Or you just take it as a 4 gram because for calculation it seems easy. So 4 ones are 4 fours are, this is 4 11s are, x is equal to 11. Means, listen, 11 gram of CO2 will produce if the 4 gram of CH4 is required. Sorry, 4 gram of CH4 undergoes complete combustion. By seeing here only, you can easily compare students. Listen here, 16 gram means they given 4 gram. Correct? So this is what? Divided by 4. If you divide this by 4, if you want 4 means 16 by 4 means 4 is the answer. So this term is divided by 4 times to get that value. Correct? Next, here 44 is there. 44. This term is divided by 4 means of course this term is also divided by 4. That is 44. So instead of 4 gram, if you take 8 gram. So before doing calculation, I simply say here 8 gram is there. If this should be converted to 8 gram means this 16 must be divided by 2. So 16 by 2 means 8 gram. Then this is also divided by 2. That means how much gram? 22. So if you calculate here, listen. This is the general reaction we already taken. But instead of that gram, they given 8 gram. 8 gram of CH4 gives how many gram of CO2? If you just cross multiply, x is equal to 44 into 8 divided by 16. This is 8 ones are 8 twos are 222s are, you get 22 grams. By seeing this reaction, you can easily say how many grams will produce. Understand? This is what the stoichiometric calibration. This one is, what is stoichiometry? Measure of the elements. How much element required to give the respective amount of a substance or a product, anything. Understood? So this is what comparing with this and this. If you want to know that one, how many moles of this is produced. Okay, so instead of carbon dioxide, students, you just compare this water molecule. Means I take here same reaction I will explain. If they say how much H2O is produced, okay, then in this reaction you have to take this 16 and 36. When 16 gram of CH4 gives 36 gram of H2O. Correct? So here we given 8 gram of CH4. Then how many gram of this is formed? So listen here. To become 8 gram, this is divided by 2. So this one is divided by 2. If it means it should be 18 gram. If you calculate here, students, x is equal to 36 into 8 divided by 16. That is 1 gram 18. So x is equal to 18 gram. So 18 gram of water is produced. Okay. If you want to say it in mole, listen. So 16 is a 1 mole. Listen, 16 gram means it is 1 mole. 8 gram means 0.5 mole. Half mole it is, right? 16 gram means 1 mole. 8 gram means 0.5 mole. Half. Next, this we don't want. Here 2 mole is produced. So, for 1 mole, 2 mole produced means, for half mole, obviously 1 mole. 1 mole of water means 18 gram. So by taking a gram, by taking volume, by taking the moles, whatever the way, students, you can easily calculate the stoichiometric ratios. And this type of problem is very, very important. Okay? So another one is like very important for 3 months. And most of the problem based on this, very important for NEET. As I told you, for NEET, so many questions, they won't ask direct question, they'll ask like this only. If this much of A reacts with B, what is the product produced? How many moles of products produced? If A is this much, what is the B we require to produce that much of product? Okay, like that comparison. If you check the NEET questions, then you will understand how the questions will arise. Okay, so this is all about the stoichiometric ratio. So students here, in this, another one is there, that is limiting reagent. I'll say what is limiting reagent. This example only I'll say. Limiting reagent. Very important part, 1 mark. Often asking question, what is limiting reagent? So what is limiting reagent? Means the reagent which consume completely in the reaction. Which consumes completely in the reaction and limits the product formed and limits the product formed. This is called limiting. The reagent which is completely consumed in the reaction and it limits the product formed, that is called as limiting reagent. And take this example, listen. If 16 gram of CH4 is there, it has a capacity to combine with 64 gram of oxygen to form carbon dioxide and water molecule. Okay? Listen. Here the question is, if 2 gram of methane combines with 8 gram methane, 8 gram of methane combines with 64 gram of oxygen. Okay? Then how much CO2 is produced? Remember this. If 8 gram of CH4 combines with 64 gram of O2, then how much CO2 is produced? Listen, if 64 gram of O2 is consumed by the CH4 means in the general reaction 44 gram of CO2 will form. Listen here, 16 gram of CH4 gives combines with 64 gram of oxygen gives 44 gram of CO2. So here they given 8 gram. 8 gram means, so 8 gram of CH4 combines with 64 gram of O2 gives rise to 44 gram of CO2. This is the general check. How many moles of CO2 will form, that we have to calculate. So students, 8 gram means this is divided by how much? 2. That is the product formula here is how much? 20. Yes, 22 gram. So by seeing this you can say, listen, otherwise another one rule is there. So 8 gram means the given mass divided by molecular mass means it is 0.5 mole. Okay, so given mass divided by molecular mass. In the before class I said how to calculate the number of moles. N is equal to given mass by molecular mass or atomic mass, whatever it is. So given mass by molar mass. Okay, given mass is how much? 8. Molecular mass is 16. So it is 0.5 mole. Correct? So this one is obviously 2 mole. So this one is 0. Yes, of course. 44 gram is there. So we produced is 22 means this is 0.5 mole. Okay? So students, according to this, if 1 mole of CH4 combines with 2 moles of oxygen, then the product formula is 1 mole of CO2. But here, the O2 molecule is completely 2 mole is there from here and here. But the concentration of the CH4 is changed. Here 1 mole is there, here 0.5 mole is there. So according to this, only 0.5 mole of carbon dioxide is formed. So in this reaction, CO2 is the limiting reagent. So CO2 completely combines with required amount of CO2 and forms 0.5 mole of CO2. So this is left in excess. It only 1 mole of CH1, only 32 gram will react with this 0.5 gram because to complete the reaction, the carbon CH4 availability is only 0.5 gram. So the species which completely combines in the reaction, so it consumes in the reaction and it limits the product formed. Okay, so compare here, 64 is there, even though the product formed is with respect to what? This CH4. So in this problem, CH4 is the limiting reagent, as I said. The reagent which consumes completely in the reaction and limits the product formed. Okay. So this is all about stoichiometry and stoichiometric calculation. So based on this, one problem is there. I'll do. how many moles of methane is required to produce 22 gram of CO2 after combustion. After combustion. Okay. So listen students. How many moles of methane is required to produce 22 gram of CO2 after combustion? Here the question is combustion of methane. So first write the reaction. Combustion means nothing but this methane is undergoes combustion in presence of oxygen. This is only if anything burns in presence of oxygen, that is called as combustion. Okay, gives always this is a hydrocarbon, means it forms as well as CO2 and H2O. The question is what? How many moles of methane requires? Okay, how many grams of methane requires? So to balance this is 2O2, this is 2H2O, you know it. Okay, so here in the question they are asking how many moles of methane we require. Just to take an here, they are given in what? Grams. So you have to take in grams. So first you listen. 16 gram of this methane combines with 64 gram of oxygen to give 44 gram of CO2 and 36 gram of H2O. This is the general reaction. The given in gram means you have to take this in gram. Next compare whatever they ask the methane as well as CO2. You just take comparison in between methane and CO2. That means 16 gram of methane gives 44 gram of CO2. You may take it in mole also. 1 mole gives 1. Okay? Later you may take it as 0.5 mole also. But if not, then also it will go. So you take here, whatever the values they given students, if CO2 given, you should take the value exactly below that CO2. If that's CH4, if they give CH4, you have to take the value exactly below that CH4. So your CO2 is there means that is 22 gram of CO2 is produced. Then how many moles of CH4 we require? How many grams? So that means what? If you cross multiply, you will get x into 44 is equal to 22 into 16. So this x is equal to 22 into 16 divided by 44. This is 22 ones are 22 fours are 4 ones are 4 fours are. So x is equal to 4. X means what? X means what? This is mass of this here, you know, mass of methane required to produce 22 gram of CO2. Understood? So here 4 gram of, here you have to write in the last. Okay, right here. So 4 gram of methane is required to produce 22 gram of CO2. Students, this is one type of equation. Okay, they directly ask how many how many moles they are asking. Okay, remember here 4 gram we got. Now we have to calculate moles. Then how can you calculate number of moles of CH4 required? The formula for number of moles is given mass divided by molecular mass. Given mass by molecular or atomic mass. Here CH4 is a molecule, that's why it is molecular mass. Given mass we got is how much? 4. Divided by molecular mass is 16. So this is 4 ones are 4 fours are. 1 divided by 4 means that is 0.25 is equal to 6.023 into 10 power 23 atoms. Here the number of mole is 0.25. Then how many atoms are there? This one is gives atoms. Okay, once you know the mole, you can compare with anything to obtain the answer. Understood? So this is very easy. The thing you have to remember is what? How to take the values. Wherever the mole is there, exactly below that we have to write mole. Wherever the gram is there, exactly below that we have to write gram. So like CO2 means CO2 only, CH4 means CH4. Okay? If you know how to write, how to take that values, then you can easily solve the problems. This trick is very, very important in NEET as well as because in board you may have so many space and time. 3 hours of time is there to answer only 70 marks. Okay, in that you may take so much time on this problem is that in nothing will affect. But in NEET, for one question you have only 1 minute for all calculation, reading the question, everything. 180 questions will be there. You have 180 minutes to answer. In that theory is also there, biophysics is also there, chemistry is also there. In that problems are there. Within that minute you have to read the question, you have to understand the question, you have to answer. So your calculation must be very fast. So at that time you can't do this lengthy process. Mind calculations is very important. Understand? Okay. So later I will explain how to calculate without calculator. Just now you understand this much. Okay? Next one question is calculate the amount of water. Calculate the amount of water produced by the combustion of combustion on 16 gram of methane. 16 gram of methane. So students, in the before calculation I did, so I have taken 16 gram of CH4 is equal to is give 44 gram of CO2. So 22 gram of CO2 I taken. So while doing calculation I did 22 into 16 divided by 44. This one I divided by 4. You just correct that this is divided by 2, that is 8. Means the number of moles is 0.5 mole of methane. You just compare that calculation. I divide this value by 4. But this is 22 ones and 22 twos, it will get not 4 gram, it is 8 gram. 8 gram means 0.25 mole is changes to 0.5. It just correct that. Okay? Here I take. So calculate the amount of water produced by the conversion of 16 gram of methane. They are directly asking amount. Amount of a substance always measured in mole. Okay. Here also you have to calculate moles. So before that, write the reaction. Combustion of methane means of course CH4 plus 2O2 gives rise to CO2 plus 2H2O. Here it is given in gram means 16 gram of this combined with 32 gram of oxygen gives 64 gram of oxygen to give 44 gram of CO2 and 36 gram of H2O. Okay. So students, the question they are asking is what? Calculate the amount of water produced by the combustion of 16 gram of methane. So we have to take methane as well as water. So here 16 gram of methane gives 36 gram of H2O. Again they are asking 16 gram of methane only. Okay, then how many grams? Again 36 grams that will come. That means what? 2 moles. Okay, that is easily I write. That is 2 moles. By comparing with students, we can easily write and take here. 1 mole of methane is equal to 16 grams. 1 mole of H2O is equal to 18 grams. Okay, here by comparison, 1 mole of this methane gives 2 mole of H2O. Okay, so this is 36 grams. You may easily calculate the moles of H2O is equal to given mass divided by molecular mass. Given mass is 36, molecular mass is 18, that is 2. Whatever the way you may use, you will get the correct answer. That is 2 moles. And that means 36 gram. Okay? You may calculate. If they ask in gram, that is answer. If they ask in volume, that is 44.8 liter. Okay, this is our report what? That stoichiometry and stoichiometric calculations. Okay, so students, you have to remember here what is the limiting reagent. Okay, in the before example I said only 4 gram of oxygen, 8 gram of methane we take means 0.5 mole of CO2 is produced. That means even though oxygen is 32 gram, but the product formula is based on the amount of methane present. So here methane is the limiting reagent. Understand? How much oxygen present in excess means listen how to compare. Here 8 gram is there. Here I take 8 gram. How to find out limiting reagent and how to find out the problem is, so listen, I compare this as 1 mole, 2 mole, 1 mole, 2 mole. Okay? Assume this is 0.5 mole. So this one is 2 mole only. So students, this is initial value. Initially, this I am not comparing this, only comparing this. So 0.5 mole of CH4 they given, 2 mole of oxygen is there. Initially, the products are not yet formed. Only reactants are there at the time T. Just we are mixing CH4 and O2. At that time, there is no reaction. So only reactants are there, 0.5 mole and 2 mole. After some time, that is final value, this is reacted. How many? Completely reacted means 0.5 minus 0.5. Initial minus 5. So next, 2 minus 0.5. If this is 0.5 is reacted, this is also 0.5 times reacted. Okay? Next, the product formula is 0.5. Now This is not 2 minus 0.5. This is 2. Wait. 0.5 mole is there. If it is reacted means initially it is 0. It is reacted 1 mole means that is 2 minus 1. Okay, this one is 0.5. This is 1 mole. So excess removed is how much? 1 mole. So students, the amount of, they may ask how many gram of oxygen left in excess. 1 mole means 32 gram. How many moles of O2 CO2 is produced? 0.5 mole means 22 gram. How many moles of water is produced? 1 mole means 18 gram. Okay, so in among these two, actually the product formula must be 1 mole and 2 mole, but the here product formula is 0.5 mole means 1 mole, even though oxygen is present in excess, because CH4 is a limiting reagent, it completely consumes and it limits the product formula. Here the product formula is based on what? How much CH4 is required, that is what limiting reagent. Okay, in the tomorrow's class I will do the example based on limiting reagent. Those are also very important.